Okay. Properties of exponents. When you are multiplying with exponents, you add them. So if we look at x squared times x, that's technically x squared times x to the first. And if you expand that, x squared is the same thing as x times x. And then we have times x to the first, so we're just really adding an x. Well, x times x times x is the same thing as x cubed. So what you do when you multiply with exponents is you just add them. So if we had something like 3x to the third times x squared, you would multiply coefficients. This one technically has a 1 as a coefficient, so you'd have 3 times 1, which is 3. These exponents here only apply to the x's. So you'd have x cubed times x squared, which would be x to the 5th, and that would be your final answer. Okay, let's say you had 2x to the negative third times 3x to the 6th. Again, you just multiply the coefficients, which would be 2 and 3. So 2 times 3 is 6. And then x to the negative 3 times x to the 6th, you add the exponents. So that would be x to the third power. Okay, when you are dividing with exponents, x to the 6th divided by x to the 4th. Let's look at the equivalent of that in an expanded form. X to the 6th would be x times x times x times x times x times x. And that's divided by x to the 4th. Well, that's x times x times x times x. Okay. If you remember that when we are dividing anything over itself, like 2 over 2, for example, reduces to 1, or you can think of it as they cancel each other out. Well, if we start canceling the x's, this x cancels with that one, those two cancel, and those two cancel, and then we are left with x times x. Well, we know x times x equals x squared. So when you divide with exponents, you're actually subtracting the exponents. So another example of that, like x to the 5th divided by x. That x has an exponent of 1, so you subtract the exponents, and 5 minus 1 would be 4, so your answer would be x to the 4th. If you have something like, let me see here, let me think. Something like this. Y. So we have something like that. A couple of different ways you could do this, as far as like the order in which you take care of things. I'm going to go ahead and subtract exponents rather than moving negative exponents first. So if we were to simplify this, I'm first going to notice that 6 over 4 does simplify as a fraction. 6 and 4 are both divisible by 2. So 6 over 4 reduces to the fraction 3 over 2. Now I'm going to take care of my variable and exponents. X to the 5th over x cubed is x squared. And then y to the negative 1 divided by y to the negative 3. Well, if we subtract the exponents, negative 1 minus a negative 3 is the same thing as adding 3. So negative 1 plus 3 is 2. So this would be my final answer. 3x squared y squared divided by 2. Okay. All right, let's look at something different. Taking a power to a power. Again, this x has an exponent of 1. If you don't see it, you just assume that it's a 1. When you have something that's in parentheses, this entire quantity is being raised to the power of 3. So essentially you're distributing the exponent. So you can think of this as being 2 cubed if we cube the 2, and then also x cubed. 2 cubed is 8, and then x cubed would just stay x cubed. So this would be your final answer right here. Okay. Let's go ahead and do this one. Same thing with this. We are going to take 2 to the 4th power, and then we're also going to take x squared to the 4th power. Okay. Now, if we're going to expand that like we did these, just to prove what we do with the exponents here, x squared to the 4th would be same thing as x squared times x squared times x squared times x squared. Well, we already know that when we multiply with exponents, we are adding them. So 2 to the 4th becomes 16. And then x squared times x squared times x squared times x squared. That's 2, 4, 6, 8. So it would be x to the 8th. So x squared to the 4th got us x to the 8th, which means we had to multiply those two exponents together. So anytime that you have a power raised to a power, you just multiply them together. Let's look at another example of that. Say you have x to the negative, or positive, let's do x to the 5th, and that will be squared. You just multiply the exponents, 5 times 2, and that would be your final answer. Okay. Couple more. When you have negative exponents, you flip it. So for example, x to the negative 3 would be 1 over x to the 3rd. So anytime you have a negative exponent, you basically put it in the opposite place of a fraction. So you put 1 over x cubed. If you had 1 over x to the negative 3 to begin with, then when you rewrite it, you bring it up to the top, and it would basically be x cubed over 1. So wherever it is to begin with, you just move it to the opposite to make it positive. So let me use our original example from before, and we're going to throw in a couple more negatives there. Let's do x to the negative 5th, x to the 3rd, and we'll do y to the 1st, no, y to the 4th, over y to the 6th. Let's do that. Okay, so if we have this, we already know that 6 over 4 simplifies to 3 over 2. So I'm going to go ahead and do that. All right, x to the negative 5th over x cubed. Subtract those exponents, so negative 5 minus 3 would be a negative 8. And you simplify to the top. And what I mean by that is, even though you're subtracting, you're kind of going in a downward motion to subtract. Your result goes up top, and then you can move them as your exponents deem necessary. So if you, once you simplify and you have a negative exponent, then you know you're going to end up having to move it later. Y to the 4th divided by y to the 6th would be y to the negative 2. So we have two negative exponents here, which means they both have to move. X to the negative 8th would have to come down below, and it would become a positive 8 there, and then y to the negative 2 would come downstairs and become y squared. And this would be your final answer.